Welcome to Saba Academy. My name is Freebody and I'll be your tutor for today. So we'll be doing a series under auxiliary projection in engineering drawing. So we'll be looking at drawing the true length, the point view, true shape, dihedral angle, piercing point, and then visibility. Okay, we'll be looking at this. So we would break it into several parts in this series. So part 1 will mainly focus on true length and then point view. Then part 2 will focus on edge view and then true shape. Right. Then part 3 will look at dihedral angle. Then the final part, which is part 4, will look at piercing point and visibility of a line, the intersection of a line and a plane. Okay, so we'll start with part 1. So we'll start with this diagram where we would draw just the true length of that line. Okay, that line in any of the views and then its point view. So let's start by getting the line drawn, then we can proceed. The first step in auxiliary projection is to pick a view, okay, to project. So we can either pick, so we indicate this as our top view and this as our front view, okay? So you either pick either one of the views, and then the idea is that the view you are going to pick is the view you are going to project. So let's pick this one first as an example, then we'll pick the bottom one too as an example. So what you do here is that for the view you pick, okay, what you do is that you draw projection lines from each point, and those projection lines are going to be your auxiliary projector. Now, the criterion for an auxiliary projector is that the projection line is perpendicular to the chosen view or the chosen line. So since we've chosen line A prime, B prime, our auxiliary projection lines are going to be perpendicular or 90 degrees to A prime, B prime. Right, so with my protractor I can draw or measure 90 degrees. Okay, I can measure 90 degrees with my protractor on either end of the line, so at the A part and then at the B prime part as well, like that. Right, and then I can have my auxiliary projectors. Mind you, auxiliary projectors are basically 10 short dashes. Okay, 10 short dashes as auxiliary projectors. Okay, so we'll call this, okay, we'll call this direction, we'll call that direction our auxiliary projector. Right, and then the next thing will be to choose our mutual view. So if you chose this as our auxiliary projector, then this one is our mutual view, and vice versa. If you choose this as your auxiliary projector, then this will be your mutual view. Okay, yeah, this will be our mutual view. So with our auxiliary projector and then our mutual view. So with a mutual view, the idea is that what you are doing, our projector for the mutual view is always in the vertical direction. It's in the vertical direction, so I can choose this, okay, as my mutual projector. Okay, as my mutual projector. So the mutual projector is aligned with the principal plane, okay, not the line itself. The mutual projector is aligned with the principal plane. Okay, so then the next thing to do, okay, the next thing to do is to draw our reference plane XY. Now the reference plane XY, I always prefer for it to be attached to our chosen view. So we chose line A prime B prime as our chosen view. So we'll draw the reference plane XY. Okay, we'll draw the reference plane XY. Okay, on a point on AB. So what we are going to do here is that we will measure what we'll do here is that we will measure points. Okay, we will measure from our mutual view, okay, and then we'll take that onto the auxiliary projector. Okay, we'll measure from the mutual view and then carry that to the auxiliary projector. Okay, I could have also drawn XY. Okay, I could have also drawn XY onto AB. I could have drawn XY onto AB. I could have also drawn XY onto AB. The idea here is that XY should be horizontal, right? So whichever point you put XY, you're going to measure from the reference plane XY onto your mutual view. Okay, so if I'm using this one, all I do is I measure the distance between XY along the mutual projector. Okay, I measure the distance between XY and then A, you see, and then XY and then B. Okay, and what I do then is that I pick a point along the auxiliary projector. So let me say some 2 centimeters away. Okay, let me choose 2 centimeters along the auxiliary projector. Sorry. Okay, and then I would have my auxiliary plane. Okay, x1, y1. Okay, so x, y, y1 on the auxiliary projector, and then xy on the mutual projector. Okay, so all I do is I will use this one. Okay, I will use this one. So point A, okay, point A lies on my reference line, so there is basically no distance between them. So if I come to the projector of A, along that projector onto the reference plane, that is where my A is, because there is no distance between them. And if I look at between XY and then B, the distance there along the mutual projector is 25 millimeters, right? So if I come to the projector of B, which is here, onto my reference plane, I would measure 25 millimeters away from that. Okay, and then I join the 2 points. And then I join the 2 points. I join the 2 points. So the line AB, okay, the line AB becomes my true length line. So if I measure AB, my AB is 76 millimeters. That's what I'm getting, right? So we'll just add a margin of error of maybe plus or minus 2 millimeters. So possibly 74, 75, 76, 77, 78, right? It's acceptable. So this is the process of drawing the true length. Okay, this is a process for drawing true length. Now, to get the point view, okay, if to get the point view, all you have to do is project parallel to your true length line. So after we have obtained true length line AB, my projection lines, right? The projection line is now parallel to AB. Okay, my projection line is parallel to AB. Okay, and then my reference plane is perpendicular towards the projector. Don't forget that your reference plane XY is always perpendicular to whatever projector it is. So if it was my mutual projector, XY is perpendicular to my mutual projector. If it was my auxiliary projector, XY is what? Perpendicular to my auxiliary projector. So for the point view, my projector is parallel to the true length line, right? So I draw 90 degrees to the secondary auxiliary projector. My secondary auxiliary projector. So I'll call this X2, Y2. I'll call this X2, Y2. Right, I'll call this X2, Y2. So therefore, I can measure. So if I take, let's say, just this point, it would appear at any point along this line. Okay, so in the next part, you would see how we would measure and then find the exact position of the point view. Okay, but then at this point, we can just place the point view somewhere here and then call this AB. So that becomes the point view of AB. So this ends it for part 1. So we looked at drawing the true length of a line, okay, by first obtaining the two views, selecting one view, and then projecting your auxiliary projector perpendicular to that line. Okay, then we have our mutual projector, which is along the vertical. Okay, then we have reference line XY, which is perpendicular to our mutual projector. Then our second reference or our auxiliary reference X1, Y1, which is perpendicular to our auxiliary projector. Then we take measurements from XY onto AB and then transfer that onto X1, Y1, and then that gives us our true length line, right? And then from there we project parallel to the true length line. We have our X2, Y2, which is perpendicular to that, and then we can find our point view AB. AB can also be at this point. It depends on the given scenario, right? So thank you for watching this video. Don't forget to like it if you liked it, and then subscribe if you want to see more of this, and then kindly share the video with your mates, your friends, and let everyone have a feel of it. Thank you very much.